Okay, for question number 3, it's given that you have to solve the following quadratic equation, and the quadratic equation is x squared plus 4x minus 8 is equal to 0. So this is question number 1, which is x squared plus 4x minus 8 is equal to 0. So A is 1, B is 4, and C is equal to minus 8. And let's find out if the roots exist for this equation or not. So we are going to find out D. So D is the discriminant, which is B square minus 4AC. B is 4 square minus 4 into A, 1 into C is negative 8. So this is 16 plus 8 4 is 32, and which gives me 48. So 48 means which is greater than 0. So roots are real and distinct. And because this is not a perfect square, so we are going to use a quadratic formula. So I'm going to write here now. So by using quadratic formula, and let's write down the quadratic formula. So using quadratic formula. So quadratic formula says that x is equal to minus b plus minus root of, this is b square minus 4ac by 2a. So x is equal to negative b. B is 4 plus minus, and we have already got b square minus 4ac, which is 48. 2 into a is 1, so this is 2. So this gives me x is equal to negative 4 plus minus under root 48. 48 is 8 into 6, so this is 8 into 6, and 8 is under root 8 is 2 root 2. So I can write it as plus minus, which is minus 4 plus minus, and 8 is 2 into 2 into 2 into 2 into 3 divided by 2. So this comes out, this comes out. So we have x is equal to negative 4 plus minus, this is 2 to the 4, root 3 by 2, this is equal to 4. So 4 is common, and this is now negative 1 plus minus root 3 by 2, which is 2. So x is equal to negative 2 plus minus 2 root 3. So either x is equal to negative 2 plus 2 root 3, or x is equal to negative 2 minus 2 root 3. So now value of root 3 is 1.732. So this is x is equal to minus 2. Value of root 3 is 1.732. And we have to calculate this. So x is equal to negative 2 plus. Now this is 2 to the 4, 6, 7 to the 14. And so x is equal to negative 2. This is negative 3.464. So 2 to the 6, 7 to the 14, 3. So x is equal to here. The answer is positive. So this is, if we subtract 2 here, so this is 1.464. And we have to give the answer incorrect to one decimal places. So this is x is equal to 1.5. So the first one is x is equal to this. I can write it as, okay, it's given that we have to write the answer correct to one decimal place. So if I round off this to one decimal place, it's 6, so we have to add 1 here. So next one is x is equal to, this is minus 5.464, and if I have to round off this, this is negative 5.5. So x is equal to 1.5, or x is equal to negative 5.5. Okay, moving on to the second part. We have to prove this identity, that sine square theta plus 1, sine square theta minus 1. So this is the second identity that we have to prove, and the identity is, it's sine squared theta minus 1 into This is tan squared theta plus 1 is equal to 0. That's what we have to prove. So I'm going to consider the LHS. This is the left hand side. So consider LHS. So LHS is sine squared theta minus 1. And this is tan squared theta plus 1 plus 1. Okay, we are going to use the trigonometric identities here. Then the first identity we are going to use, I'm going to write down the identities that we are going to use. And the first one is sine squared theta plus cos squared theta. We know that it's equal to 1. So if I bring 1 to the right hand side and take cos squared theta to the left hand side, so this is sine squared theta minus 1 is equal to negative cos squared theta. So instead of this, I can write this is negative cos squared theta into. Now we know that. So this was the first identity that we use, and also 1 plus tan squared theta is equal to secant squared theta. So instead of this, I can write this is secant squared theta plus 1. Now, okay, so we know that this secant squared theta is 1 upon cos squared theta plus 1. This gets cancelled. This is equal to negative 1 plus 1, which is equal to 0. So that is equal to RHS. So hence it is proved. Okay, so second part is also done, and use graph sheet to answer this question. Take 2 centimeters equal to 1 unit along both the axes, and we have to plot A, B, C, where these reflect A and B on the x-axis and name them E and D. Okay, so let's get our Cartesian plane first. So first we have to plot, the first part says that A, B, and C, we have to plot A, B, and C. Okay, so if this is the Cartesian plane, and we have to plot A, B, and C. So this is um, coordinate axis. So this is x dash, y, and y dash. Okay, this is the origin, and it's given that we have to take 2 centimeters equal to 1 unit. So you can take accordingly 2 centimeters as 1 unit. And I'm going to, let's say this is 2 centimeters, so this is 1 unit. This is 2. You can take, you have to take 2 centimeters 1 unit on the graph sheet. So because this is the interactive panel, so I'm going to take this 2 divisions as 1 unit. So this is 1, this is 2, this is 3, and this is 4, and this is 5. Okay, next one. So we have to plot. It says that first point is a0 comma 4. So a0 comma 4. So 0 comma 4 means this is on the y-axis. So this is the point 0 comma 4. So this is 0 comma 4, which is point A. Okay, next one is b0 1 comma 1. So 1 comma 1 is here. So this is b1 comma 1. Next is c4 comma 0. So this is c, which is 4 comma 0, and it's on the x-axis. Okay, now the next is to reflect A and B on the x-axis and name them E and D. So we have to reflect A and B about the x-axis. So reflecting A and B on the x-axis and name them as A and D. So A has to be named as E. So I'm going to reflect A on the x-axis. So this is A, which is 0 comma 4. So on x-axis it has to be reflected above the x-axis. So that means x-axis is the mirror axis. So a 0 comma 4 we here is this is 0 comma negative 4. So this is E. So we have E0 comma 4. So A is reflected as E, and the next one was to reflect B on x-axis as D. So we have to reflect B on x-axis as D. So B, which is 1 comma 1, so this becomes 1 comma negative 1. So 1 comma negative 1. So this is B, and it becomes 1 comma negative 1 on x-axis, and we have to name it as D. So this is D. So this is D. D. So B is reflected as D. Okay. Now, on part C, reflect B through the origin and name it. So we have to reflect B through the origin and name it as F. So let's reflect B through the origin. So reflecting B through the origin means we are going in the third quadrant. So it becomes -1, -1, and we have to name it as F. So we have to name it as F. So this is F. Okay, now write down the coordinates of F. So coordinates of F. So coordinates of F are -1 and -1. -1, -1 are the coordinates of F. Okay. For part D, reflect now B and C on the y-axis. So and name them as H and G. So we are reflecting B and C on y-axis, and we are naming them as B and G. So to reflect points B and C on y-axis, we have to draw a vertical line through the points B and C. Okay, so B on the y-axis. So that means this is a reflection of B here, which becomes -1 and 1. And we have to name it as H. So this is H. So the reflection of B on y-axis is H. Now the reflection of C on y-axis. So C on y-axis is this one about y-axis, which is -40, and we have to name it as G. So this is G. So C is reflected as G on y-axis. And now the coordinates of H are -1, 1, and coordinates of G are -4 and 0. Okay, so D is done. Now join points A, B, C, D, E, F, G, H, and A in order and name the closed figure. So we have to join the points. So let's join the points, and we have to name it. So the first one was A. So join A, B, A to B. So let's join A to B. So join A to B. Okay, I'm going to use different line here. So let's join A to B. Let's join A to B. There's a lot of different ones. Let's use. So A to B, then B to C, and C to D, D to E, E to F, F to G, and then G to H, and H to A. So this is a figure that we have got, and we have to name the closed figure. So this closed figure has 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8 sides, and this closed figure is called trapezoid. Name of this closed figure is trapezoid. So this is trapezoid. Okay. So we are done with part 3 as well. We have answered all the parts. So question number 3 is done. Moving on to question number 4.